Okay, today we're doing our liquid properties notes. We're going to start off with our two-column notes. You need to write everything. So let's start off with surface tension. Surface tension is defined as a force that acts on the particles at the surface of a liquid. So if you look here, think of this as the penny with a water bubble on top. The molecules have a stronger bond right there at the surface where the arrows are pointing. Alright, it's much stronger than down here within the water. So water molecules are more attracted to each other than they are, say, the air molecules above it, which makes it stronger, which kind of acts like a little thin skin that helps them stick together at the surface of the liquid. So it kind of forms a very thin layer there. Now, remember in class we did the experiment. I did that demonstration, but I didn't tell you why the water stayed in. Well, what I did is think of this right here. This is the jar. This little black area right here that I said was the penny, think of this as a piece of screen. I put that screen there. The water can easily flow through those little holes within the screen. When I flip it upside down, the water, this is what's happening with each one of those little individual squares on that screen. The water has created a very tight bond and has created a little thin film. When you put all those thin films together, all those little multiple squares on the screen, that is strong enough to hold back all that water. And that is surface tension right there. And that's how you would do it. Now, how can you reduce that? Well, soap and detergents will break the bonds. So if I spread soap all over that thin layer of screen, there's no way it would work because soap breaks the bonds, comes in here, splits them apart, and they become weak, and it will no longer hold the water. Now, real-life applications, why do we need to know about it? What's its uses in real life? Well, wax on cars. By waxing our cars, it causes the water to bead up and roll off the car quicker and also keeps the dirt from building up on it. When you go tent camping material will also reduce surface tensions, which allows the water to run off the tent instead of into your tent. Finally, soaps and detergents that we use for cleaning dishes and washing our clothes helps to break down that stuff better, and so therefore our clothes are cleaner. Now let's talk about viscosity. Viscosity is defined as a liquid's resistance to flow. Basically, in a 6th grade definition, it's how fast or slow liquids go. So liquids that flow very slow are liquids that would normally have a high viscosity. We say that they're more viscous. More viscous means they have more resistance to flow. They don't want to flow very easily. They want to resist moving. Therefore, they're going to go very, very slow. Examples of liquids that are very viscous or have high viscosity would be honey, molasses, liquid soap. Now, liquids that flow very fast have low viscosity, meaning they're less viscous, they have less resistance to flow, meaning they don't have a lot of resistance. They just want to go quickly, and you can see that when you pour water or juice or pop onto the counter, it flows out pretty quick. Therefore, it has low viscosity. Now, what about viscosity in real life? Why do we care? What's its applications for us? Number one, engine oil. Knowing that helps reduce the wear, the friction on our engine parts, therefore saving our engine so it lasts longer. Suntan lotions, lava flow predictions. If the lava is very viscous, it's going to flow slower, therefore giving people more time to evacuate homes. Even blood flow medication. Some people have thicker blood, and so they give them blood thinners to help reduce the clots. So therefore, viscosity is used in blood flow medications. Finally, our final question. Explain the difference between two liquid properties. Give one real example for each one of them. Okay, when you're done with that, make sure that's done for class. I'll see you shortly.